So welcome back to Tech Talks. We are moving on with more examples, general examples on partial fractions. So we are going to look at more examples on partial fractions. On partial fractions. So we are starting with one. Express x squared all over x power 4 minus 1 in partial fractions. So want to express these numbers now they are generated. It depends. You will only see which type of the fraction is this. Now by me saying this is already a proper fraction. So what we are going to do, we are going to first factorize down. You say consider x power 4 minus 1 is the same as x squared, the whole of it squared minus 1. So we factor this is a difference of two squares. So we are going to have x squared minus 1 into x squared plus 1. So what we're going to do is this. Again, this one is a difference of two squares. We're going to have x plus 1 into x minus 1 into x squared plus 1. So we say this implies that when you say x squared all over x, instead of x power 4 minus 1, we are going to put this expression as x plus 1 into x minus 1 into x squared plus 1. This is the same as the first two are linears. So we are going to say a out of x plus 1 plus b out of x minus 1 plus this one is the same as cx plus d, because the product which cannot be factorized, out of x squared plus 1. So we go ahead and we get the LCM. So we are getting x squared all over x plus 1 into x minus 1 into x squared plus 1 is the same as, the LCM remains the same as x plus 1 into x minus 1 into x squared plus 1. So the whole of that one divided by that, we are getting as the x plus 1 crosses. So we are remaining with a into x minus 1 into x squared plus 1 plus the whole of that one divided by that, we are going to remain with b into x plus 1 again into x squared plus 1 plus the whole of that one, this one divided by that, we are going to remain with x plus, we are going to remain with cx plus d into x plus 1 into x minus 1. So this one and this one crosses. So we are remaining with x squared equals is the same as a into x minus 1 into x squared plus 1 plus b into x plus 1 into x squared plus 1 plus cx plus d into x plus 1 into x minus 1. So we can use several methods. I'm going to use the covering up method so that we can try to easily get these constants. You can say using the covering up method, So we want to use the covering up method. So when we are using it, we can start by saying if x equals 1, we are going to substitute in. If x equals 1, we are having 1 squared remain as 1 equals 1 plus 1, it affects that value comes 0 plus b into 1 plus 1, we are getting a 2 into 1 squared is still a 1, 1 plus a 1 remains as a 2 plus x is already 1 minus 1 affects everything there. So there we are getting 0. So what am I getting? I'm getting 1 equals 2 for b. So what is b alone? B alone equals a quarter. So I've finished getting the value of b as a quarter. We still go ahead and see how can eliminate these ones, because I've decided to use the covering up method. We are proceeding with it. I can say if x equals 0, we are substituting in any value such that we can easily eliminate some of these unknowns. So if x equals 0, on the left hand side we are going to have 0 squared to remain as 0 which is equal to 0 minus 1 will remain with negative 1, 0 squared. So the whole thing here we're having a into negative 1. We come to plus. We are coming 0 plus 1, which is 0. We are remaining with only b into 1 plus. We are coming here 0 times a c. We are remaining with a d into negative 1. We are having a d into negative 1. Now we go ahead. This is 0, which is equal to negative a plus b minus a d. But do we know our value of b? We know b as 4. So we substitute it. We are having 0 equals negative a plus a quarter minus a d. Now I'm going to bring this one there. I remain with negative a minus d equals negative a quarter. Can we divide this out by negative 1? So we are going to have a plus d equals a quarter. We say this is the first equation. So from there, we are going to generate several equations. Again, I'm going to say if x equals maybe negative 1, such that you can substitute in, you can say if x equals negative 1. So I want to substitute in the value of x equals negative 1 in the whole of that expression, and I see what will come out. So if we substitute negative 1 squared, we are going to get 1 equals negative 1 minus 1, we are getting a negative 2, so it is a into negative 2 into negative 1 squared, we are getting 1. 1 plus a 1, we are getting a 2. We go to plus, there is a b here, into negative 1 plus a 1, we are getting a 0. 0 times anything, it becomes a 0. We come to plus. Everything it is affected is also 0. So we are having 1 equals negative 4a. So what is a alone? A is negative a quarter. After coming out with a is negative a quarter, we can substitute in equation 1 to obtain the value of d. You can say put a equals negative a quarter in 1. What was equation 1 saying? Was saying a plus a d equals a quarter. So do we know our d? Our a is already negative a quarter, negative a quarter plus d equals a quarter. So can we go ahead and we substitute in? Let's substitute in. So making d alone, d is going to be a quarter plus a quarter. So d alone equals a half. We have already got the value of a, we have got the value of b, so we are remaining with the value of c. So we go ahead from the expression which we have already got as x squared equals is the same as we had a into x minus 1 into x squared plus 1 plus b into x plus 1 into x squared plus 1 plus another one was cx plus d into x plus 1 into x minus 1. Then I can say if x equals a 2, if x equals a 2. Can we substitute in the value of x equals a 2? We substitute. What is a 2 squared? We are getting a 4, which is equal to a into 2 minus 1, we are getting 1 into 2 squared, we are getting a 4 plus 1, it is a 5, plus b into 2 plus 1, we are getting a 3, into 2 squared, we are getting a 2, we're getting a 4 plus 1, 5, plus, this is 2c plus a d into 2 plus 1, we are getting a 3, 2 minus 1, 1. So can we try to open this? Is 4 equals 5a plus 15b plus, this times this we are getting 6c plus 3d. I can call this one my equation star. Now, we are going to put all the unknowns which we have been getting in this equation. So can we substitute them there? We substitute them there. So can we substitute it? Do we know the value of A? A is already a negative. A is a negative a quarter. So we are getting 4 plus 5 into 5 into a quarter, because A is a quarter, is a negative a quarter, plus, do we know the value of B? B is positive. B is a positive a quarter. Then we go ahead, plus 6C plus 3 into the value of D is already a half. So can we go ahead? 4, I say 4 equals 4 minus 5 out of 4 plus 15 out of 4 plus 6C plus 3 out of 2. So we try to collect like terms. This one comes here, we are getting a 0 equals, when we try to add these ones here, I'm getting 10 out of 4 plus 3 out of 2, then plus a 6C. So can we try to get the LCM? The LCM is still a 4 there. 4 divided by that, we are getting 1, that is 10, plus this divided by this, we are getting a 2. 6 plus 6C equals 0. So we are getting negative 16 out of 4 equals 6C. We can reduce mathematically. By 2, I'm getting a 3. By 2 here it is 8. Again we reduce, we go in. What is C alone? C alone is negative 8 out of 12. So we reduce again by 3 or by 2. By 2 I get negative. By 2, let's use by 2. By 2 get negative 4 out of 6. Again by 2, negative 2 out of 3. So that's the value of C. So I've come out with all of them. Then we are going to rearrange it very well. And we say, therefore, x squared out of x power 4 minus 1 is the same as, we had the A out of x plus 1 plus B out of x minus 1 plus cx plus D out of x squared plus 1. So, do we know the value of A? The value of A is already negative a quarter. We shall have negative 1 out of 4 into x plus 1 plus the value of B. The value of B is already a quarter. So we are going to have 1 out of 4 into x minus 1 plus, what is the value of C? The value of C is already negative 2 out of 3 x plus the value of D is already a half all over x squared plus 1. So we got, this is the same as negative 1 out of 4 into x plus 1 plus 1 out of 4 into x minus 1. Then we get the LCM with 6. So here we are going to get plus, then that is going to be 3 minus 6 divided minus 4x all over 6 into x squared plus 1, which is given as x squared all over x power 4 minus 1. That's how we can express a given number into the required partial fraction. You can see the number was trying to be somehow complex. So when a number has got that kind of complexity, I expect you to do the best by rationalizing if possible, and again by doing what we call the factorization deeply, and then know how to solve the simultaneous equations.